Hello. In the following tutorial series, I will show you everything you need to know about how to set up mobile pedestrian system inside your project. The first thing you need to know is how to set your own pedestrian model to work inside the system. To illustrate that, I am using the Toon City People asset made by 6 Games. They were kind enough to provide me a model to share for free with the package. As you can see, the package contains a lot of pedestrian models and variations, so it has everything you need to populate an entire city. Now let's move to actual pedestrian integration process. The first step is to create a prefab from the 3D model. This prefab will be instantiated by the system and used inside the application. Since this model includes a lot of variations for clothes and other features, I will remove those and leave only one variation. Create a folder to store the prefabs. Name the pedestrian male one and drag and drop it inside that folder to make a prefab from it. Open the prefab and add the pedestrian component on the root game object of the pedestrian. This will automatically add a rigid body and an animator component. Now we'll be focusing on the animator setup. The pedestrian system uses the animator component to move characters around, so apply root motion must be enabled. Select the appropriate avatar for your character. If you have multiple characters, ensure each has the correct avatar. To learn more about creating the avatar, check the documentation linked in the description. Now assign the controller. Pedestrian system provides a basic animator controller called Gley Pedestrian Controller. Located in Assets, Gley, Pedestrian System, Graphics, Pedestrian, Controllers. The controller consists from a move blend tree and 3 animations: hit, revive, and destination reached. By default, the move blend tree is enabled, and the other animations are enabled using trigger parameters such as hit, no waypoint, and has waypoint. To move the pedestrian around, the system controls 2 float parameters, speed and angle. Those parameters are used to select the appropriate animation from the blend trees. The speed is used to set the idle, walk, or run animations, and the angle is used to select the direction, straight, left, or right. The system includes basic animations, but for smoother and more realistic movement, you may want to use additional or higher quality turn animations. Remember, pedestrian movement is driven by the animations, so any changes to how a pedestrian moves will require corresponding changes to their animations. In another video, I will cover how to create your own animator controller, but for now, we'll use the existing one. We are done with animators for now. It is time to set up the pedestrian component. A pedestrian will walk at a speed randomly selected between the minimum and maximum speeds. This creates variation between pedestrians and makes them look more realistic. To set the same walking speed for all pedestrians, make both values equal. The type of the pedestrian is relevant only if the movement of specific types of pedestrians needs to be restricted in certain areas. Otherwise, the type is not important. The trigger length represents the distance at which a pedestrian sees an obstacle and tries to avoid it. A trigger of this length is automatically generated on the pedestrian. The Has Ragdoll checkbox indicates if the current pedestrian has a ragdoll prefab associated with it. The ragdoll field represents the actual prefab. The pedestrian game object is automatically switched with the ragdoll game object if it is hit. When configuring a pedestrian, always press the Assign Pedestrian button. It will tell you what is wrong with it and what it needs to be changed to properly work inside the system. For instance, now it says our pedestrian doesn't have colliders, so let's add some. I like to place my colliders in a holder to be easier to find and modify later. Try to use primitives for colliders, capsule, cylinder, or box colliders for improved performance. In this case, I will use a capsule collider. Set the height to 2, the radius to about 0.2, and move it up to 1 meter. The collider must be placed right at the bottom, otherwise the character will sink into the ground. Any pedestrian can transform into a ragdoll upon impact. This is an optional feature that can be enabled using has ragdoll property. A new ragdoll prefab needs to be created. Create a new prefab from the 3D graphics of the pedestrian and add it to any scene. Right-click on Hierarchy and select 3D Object Ragdoll. This will open the ragdoll creation window. Assign all the corresponding bones from the character hierarchy. Select each bone and check the position. The name of the bones will differ from a character to another. The position is important since a correctly made character will have those bones inside it. After the assignment is complete, press the Create button. Colliders and joints will be automatically added to the character. Some adjustments might be needed. Unity has a great tutorial on how to create a ragdoll. Please follow it for more available customizations. Add it to the Prefabs folder. After the ragdoll is created, assign it to the pedestrian component. Press the Assign Pedestrian button again to verify that the setup is correct, and this time it should be successful as you can see. There is a warning. You can ignore that for now. I want to explain you in more details how the layers work first, and then we'll also fix this warning. To be used inside the game, a pedestrian needs to be added inside a pedestrian pool. To create a pedestrian pool, do a right-click on the project window, select Create, Pedestrian System, Pedestrian Pool. A pedestrian pool is a collection of all pedestrian prefabs available in the current scene. It ensures that the system has access to the necessary pedestrian models for instantiation. Add all the pedestrians you want to use inside the pedestrian pool. Each entry represents a different pedestrian prefab that will be available in the scene. When adding a pedestrian type to the pool, the system ensures that at least one pedestrian of each type will be instantiated. I will come back later with more explanations about what percentage and don't instantiate mean. For now, we'll use a single pedestrian, so it is not relevant. Now I will create an empty scene to demonstrate this process from scratch. I will add a plane to act as ground. This should be enough. There are a few steps needed for preparing the scene before adding the pedestrian system. The first one is the layer setup. Go to Tools, Gley, Pedestrian System. The Settings window will open. Dock it for easier access. From the Scene Setup menu, select Layer Setup. The mobile pedestrian system uses layers for performance optimization, so understanding how layers work inside the package is essential for a proper setup. The layers you are seeing here are the physics layers. Since this is an empty project, all of them are empty. That's why you are seeing UI on everything. If you are not using an empty project, you might have layers already defined. I will briefly explain now for each category what is used for and what layers should be selected there. Pedestrians will walk only on objects assigned to layers marked as ground layers. Ensure all terrain, roads, sidewalks, and other surfaces the pedestrians will walk on are included in this layer mask to guarantee proper functionality. If not selected properly, pedestrians will fall through ground. The pedestrian layers are exclusively for pedestrians. Make sure all pedestrian colliders are assigned to layers within this mask to prevent issues such as pedestrians colliding or spawning on top of each other or various console errors. Building layers are intended for static objects such as buildings, lampposts, and other stationary elements near the road. Obstacle layers should contain dynamic objects that may intersect pedestrian paths. Pedestrians need to detect and avoid collisions with these obstacles. Player layers are designated for the player's car or character. It is distinct from dynamic objects as it allows for setting specific actions for the player that differ from other objects within the application. I will define some layers that will be used in this tutorial: road, pedestrians, static obstacles, dynamic obstacles, and player. Later, I will assign scene objects to those layers to illustrate the functionality. Now I will add them to the Layer Setup window. It is time to set the grid. To do that, open the Scene Setup and select Grid Setup. To accommodate large scenes, the system employs a grid-based setup. This approach ensures that the scene's dimensions do not impact the pedestrian system's performance. Utilizing a pooling system, the system spawns and removes pedestrians selectively around the player, creating the illusion of high pedestrian density with fewer pedestrians, thereby improving performance. The grid cell size is in meters. Usually something between 50 and 100 meters works best for cities. I will use a smaller value since the plane I just created has only 10 meters. I will set the grid cell size to 5 meters. Click Regenerate Grid to update the grid size at the new dimension. The grid is used to mark the cells around the player as active and the other ones as inactive. In another video, I will explain how the grid system works in detail, as it's an important part of the overall system. However, for now, this information should suffice. The View Grid button will display the grid inside the scene view. But since my plane is white, the grid is not visible. Let me change that color. Now we can see the grid, and as you can see, it updates every time the value changes. I am going to assign the layers I just created to the objects. I will add the plane on the road layer and our pedestrian prefab on the pedestrians layer. If I press the Assign Pedestrian, the previous warning went away. The system verifies if the layer on which the pedestrian is was assigned also to the Layer Setup window. If those are different, you will see the previous warning. Now we are ready to create the first path on which the pedestrians will walk. To make this scene more realistically, I will add an intersection on it. Go to Gley, Urban Assets, Graphics, Environment, Prefabs, Roads, and add intersection 4 roads prefab inside the scene. Let me also change that plane color for a better view. The mobile pedestrian system uses a path drawing tool to help you create paths for pedestrians. To draw a path, open the Settings window and select Path Setup and then Create Path. Press Shift plus left-click to add a path point. When you click a second time, a Bezier curve will be drawn between those 2 points. You can edit the curve by moving the control points around, and you can change the shape by moving the anchor points around. Press Ctrl-Z to undo the changes. If you click between 2 points, another point is added. If you right-click on an anchor point, it will be removed. You can add as many points as you like on the Bezier curve. From the Edit window, you can customize the colors and switch the Move tool to a 3D gizmo. When you are happy with the curve, press Generate Waypoints, and this will generate the actual waypoints the pedestrians will use. You can view the waypoints and path width by using the toggles. You can change the waypoint distance and press Generate again. Also, you can customize the path width. Pedestrian will not walk exactly on the waypoints. They are using a random offset and will walk on the entire path width. So make sure the path width is always narrower than your sidewalk. From here, you can specify which pedestrians should be allowed on this path. Currently, I only have the normal pedestrian type, so let's create another category. Navigate to Scene Setup and select Pedestrian Type Setup. Add a new category named Worker and press Save. This new category will be saved and available to use. You can edit a path at any time by opening Path Setup and then View Paths. All available paths will appear here. Press Select on the path you wish to edit, and the previous edit window will open and you will be able to change everything. The newly created category is not available. This is nothing to worry about. It means that the plugin is not enabled. To verify if this is the case, open the Build settings. As you can see, the scripting defined symbols does not contain the Gley pedestrian system definition, and that means that the plugin is not activated. To activate the plugin, press Apply Settings. Wait for the scripts to compile and close, and open the Build Settings window again to refresh. Now the pedestrian defined symbol is there. There are a lot of errors inside the console, especially Float 3 related. This means that the required burst compiler package is not added. Add it from the Import Required Packages window by pressing Install All. Wait for the installation to finish and the errors will go away. Now you can select just the worker type, and that means that only the pedestrians marked as worker will be allowed here. If you remember, our pedestrian was marked as normal, but you can open the prefab at any time and change the category. For now, I will let it to normal category. Let's make sure normal pedestrians are allowed on our path. Press Generate Waypoints. You can create as many paths as you like. From the View Paths window, you can delete an existing path simply by pressing the Delete button. Using this editor tools, you should draw the pedestrian path like this on the entire scene. My path looks good. To be able to test it in play mode, we have to press the Apply Settings. Every time you change something to the waypoint configuration, you have to press the Apply Settings button, otherwise the changes will not be transferred into play mode. When Apply Settings is pressed, the editor waypoints you just created are converted into a simplified version used in play mode for performance reasons. In large scenes, this process might take a long time. I forgot to mention that if you press on the first point on a path, the path will close. Also, you can use the Close Path button. If Apply Settings is successful, we are ready for the first test. To make the pedestrian created earlier to move inside the scene, the pedestrian system component needs to be added. I like to add my scripts on an object called Scripts Holder for a better management. I will create that object and add the pedestrian system component on it. It requires a player. This should be your real player, human or car. The player is used to spawn pedestrians only around the player object. By doing this, the system creates higher density with fewer pedestrian prefabs, since pedestrians are not present in unseen areas from your map. I will create an empty game object and use it as a player since this is just a test. For the number of pedestrians, I will use 1, since I only want to instantiate a single pedestrian to make sure it works. Here I will select the pedestrian pool created earlier. Let the other settings as they are. I will go through them later. Now let's test and see if it works. Our pedestrian is instantiated on the sidewalk and walking, but something doesn't seem okay. I will stop and check the layers. If you have this kind of problems, usually the layers are not set up properly. Indeed, the road prefab is not on the correct layer. I should assign it on the road layer, and now it should work. Now it seems to work properly. When he will run out of waypoints, he will turn around and walk in the opposite direction. It looks like the road prefab is not on the ground, and the pedestrian cannot climb on it. This is not a problem right now. We are focusing on pedestrian movement. Now it is time to make him cross the road. I will start by moving the intersection prefab lower. Now it is time to draw the waypoints on the entire intersection. I will draw a path on each sidewalk. These paths need to be connected so that the pedestrian could cross between them. To do that, navigate to Path Setup and select Connect Paths. This will open the Connect Paths window. The window will display a list of all existing connections within the scene view. Currently, there is none. So let's create the first one. Notice that all waypoints that allow connections will turn into blue clickable squares. Click on any blue square and it will turn to green. Select a destination waypoint. A connection will be generated between those 2 points. As you do with paths, you can use the handles to adjust the shape of the connection. You can set a path width and a waypoint distance. When you are happy, press Generate Selected Connections. This will generate actual waypoints. Using the waypoints and width buttons, you can see the generated waypoints and connection width. I will connect the remaining paths and generate the waypoints. Everything is done. Don't forget to press Apply Settings since the waypoints changed. Let's see if our pedestrian is able to cross the road now. It looks like that capsule is not allowing him to go up. For that, I will show you a simple workaround. Add at the bottom of your pedestrian a box collider. And turn it at 45 degrees on X and Z axes like this. Make sure it has a ramp-like shape in the front. Scale it down a bit. And add the zero friction material that comes with the package. An important thing is to make this collider to collide just with the ground. For that, open the project settings, go to the tags and layers, and create a new layer just for this collider. I will call it Foot Collider. Using the layer collision matrix, make sure it collides just with the road. It is very important to not collide with itself. Assign the just created box collider to this layer. Now the pedestrian should climb that sidewalk. The capsule collider needs to be moved up a little since it is still touching the sidewalk before the newly created collider. Now it should work. As you can see, it really does. To prevent pedestrians from crossing the road randomly, the street crossing component can be used. Pedestrians will be required to stop until the crossing component signals that it is safe to continue. As I said, I prefer to add component to holders for better management, so I will create an empty game object and add the street crossing component on it. This component is controlled externally and can be synchronized with an existing traffic system, or its behavior can be programmed to meet specific needs. The name of the component is important since the API require this name to access the component. I will call it Test Crossing. Using the Add Stop Waypoints, select the waypoints on which the pedestrian should stop and wait. Now select the direction waypoints. From a stop waypoint, a pedestrian can go in these directions. If it moves in this direction, it should not wait. Also in this direction should not wait. It should wait only if its direction is this one. So the direction waypoints mark the stop direction. Let's mark them accordingly. The setup is done. Because you added an intersection component, you have to press again the Apply settings. Now, as you can see, the pedestrian will stop there and will wait indefinitely because the state of the crossing component will never change. It will change only from a script, so I will create a simple script to change that component automatically as an example. Assign the newly created script to the script's holder object, and let's write the code for changing the crossing state. I am creating a timer and a variable to store the time passed. Inside the update method, if the pedestrian system is initialized, I am increasing the time variable. If my variable is greater than the timer, I will reset it. Now I will reset the crossing state. I am using the Set Crossing State API method. I pass the crossing name I want to change, in this case test crossing, and for the value I will use the opposite value of the current state. So I am using Get Crossing State method and flip the result. Now the crossing should change every 10 seconds. To visualize the state of the crossing in play mode, navigate to Debug window and enable Debug Street Crossing. Hit play and notice the pedestrian waiting for the crossing state to change, and only after it will continue on its path. Each intersection should have its own crossing component to control it, and it can be controlled by your existing car traffic system to keep the pedestrians in sync with your cars. If you are not happy with the position of a waypoint, you can edit it manually. Go to Waypoint Setup and select Show All Waypoints. This will show all pedestrian waypoints from the scene. Using the toggles above, you can view the connections and the pedestrian types that are allowed on them. Select any waypoint you want to modify, and the Edit Waypoint window will open. From here, press Select Waypoint, and the waypoint game object will be selected in hierarchy. Using the gizmos, you can positionate the object as you want. When it is in the right place, press back and apply settings. As I said earlier, after any waypoint changes, you have to apply settings before entering play mode. Now let's create something more interesting. If you remember, we have two pedestrian categories, normal and worker. Let's make workers to walk only on the top part of this crossing and normal pedestrians on the bottom part. For that, select an edge waypoint on the top part. As you can see, only normal pedestrians are allowed. Let's change that and make only workers to be allowed. Press the Set button. That will propagate the changes to all neighbors. As you can see, the entire sidewalk now allows only workers. Move on the other sidewalk and do the same thing. For a better view of the pedestrian routes, navigate to Pedestrians Route Setup. Change the colors for a better view. As you can see, normal pedestrians are allowed only on the red waypoints. Let's remove the one from above by changing them on this waypoint. And also on this one. Now let's make all bottom waypoints to accept normal pedestrians. Select the edge waypoint and select normal pedestrians on it. Notice the propagation on all unedited waypoints. Mark that crossing as worker. Now on the top part we have workers, and on the bottom part we have normal pedestrians. Use the view buttons to toggle between them. If you remember, our pedestrian had a normal type. Let's make the included pedestrian as a worker type. Add it to the pedestrian pool. Increase the number of pedestrians to 2. Since you changed the pedestrian routes, you have to apply settings. Enter play mode. As you can see, our pedestrian is on the bottom part, being a normal pedestrian. The pedestrian marked as worker is on the top part. This is exactly what we wanted. You can increase the number of pedestrians. I will use 20. As you can see, on the bottom part are spawn only normal pedestrians, and on the top part only workers. This fully respects the previously made setup regardless of the number of pedestrians used. Using the information from this tutorial, you should be able to fully implement the mobile pedestrian system into your own project. This covered the basics. For more details, you can check the online documentation. In future tutorials, I will cover the waypoint priority setup, the pathfinding, the debug window, and many more features. Subscribe to the channel to stay up to date with future releases. If you have any questions, you can reach us on the support channels listed on our asset store page. Thank you for watching.